Hello everyone, in this video I'm gonna show you what is stable diffusion and how it's work. Basically stable diffusion is a model which is used for image generation and it's mostly uses a model in image generation. So this is the example code of stable diffusion 1.5. Here I'm use pre-trained open source stable diffusion model of version 1.5. It's from Hugging Face, and this is my input, a dog wearing hat. When I run this code, it generates a image of dog which wear hat. So let's see. As I run python 3 stable diffusion.py, firstly it download or fetch all the model from Hugging Face. It takes some time, which depend upon the size of the model. Within 1 minute, it generates output image. This is the output image from this code. Now I'm gonna explain you the working behind this whole process, how stable diffusion work. So for this, first we need to know some term like what is generative learning method, what is GAN, what is diffusion model, and what is transformers. So generative learning is a process where the model learn from memories and existing knowledge, means it integrate the new ideas with the existing ones. Then GAN is a deep learning model which is used to generate images. It is a combination of two neural network which oppose each other, means both neural network model has opposite nature. It is used for image generation, video generation, and voice generation. GAN has some limitation like model collapse, lack of diversity in image, high training time, and these are not easy to train due to adversarial nature. Then we have diffusion models. Diffusion models are better than GANs. It is used for image denoising in painting, to generate super resolution images and generate images. It has two major domain process like forward diffusion and reverse diffusion. In forward diffusion process, image is corrupted by gradually introducing noise until the image become completely random noise. Then in diffusion model we apply reverse diffusion process, which is a process of recovering data from Gaussian noise by gradually removing the predicted noise at each step using a series of Markov chain. As a result, it produces more diverse images and it not suffer from model collapse because it has the ability to preserve the semantic structure of data. But training time become high because each Markov state need memory for prediction. Then we have transformers. Transformers are semi-supervised machine learning model. It build on the architecture of encoder and decoder. It take input sequence and generate output sequence. Some applications of transformers are sentiment analysis, translation, text summarization, text classification, question answering, text generation, and image classification. Common example of transformers are BERT, DistilWort, T5, GPT, all series of GPT, and CLIP. Transformers work with both TensorFlow and PyTorch. Basically, transformer take text, then do tokenization and embedding, means convert the input text into tokens, then vectorize that, then apply positional embedding on the text which know the order of each token, and then it has stable attention layer which find the correlation between different words and know the input and know the contextual structure of the data. Then it have encoder and decoder, linear layer and softmax layer, and generate output based on the input text. Then we have latent diffusion model. So latent diffusion model are combination of GANs, diffusion model and transformers. It has the perceptual power of GAN, the detail preservation ability of diffusion model, and the semantic ability of transformers. It use generative learning method. It generate more more diverse image or highly detailed images. These are more durable and efficient and more memory efficient as compared to other models. So latent diffusion model have the semantic feedback from the transformer and is an application of diffusion process in latent space instead of pixel space. Stable diffusion is just a rebranding of latent diffusion model with the application of high resolution image, and it uses clip as a text encoder. Clip is a pre-trained transformer which embed text or image into latent vector. Stable diffusion is a deep learning text to image generation model. It introduced in 2015 and released in 2022. It generates detailed image based on the given text description. Its code and model weight are available online, or it's open source. You can, I used this model from Hugging Face, which is open source. Application of stable diffusion is to generate images from text. It's used for image modification, image inpainting, and to remove noise from the images. It need modest GPU with at least 8 GB of VRAM to run the code. As you can see in this image, this is the structure of stable diffusion. It has the perceptual power of GAN, which use autoencoder and has detail preservation ability from diffusion model. Then it has clip transformers, then use UNet autoencoder for cross attention layer, which is used to know the correlation between the each word of given input sentence. Then it use text to image synthesis or image to image synthesis, which is given by LDM Python API. So this example is a 1.5 version of stable diffusion. You can download the open source weight of this model from huggingface.co. It is basically used to generate image from text. If I talk about real world use cases of this stable diffusion model, it is used in education and for research on generation model, used in video games to generate portrait and characters, used in architecture design, and it used for artwork generation. If you want to perform other tasks from this stable diffusion model, you have to fine tune this model by using the new data. This is all about stable diffusion models. Hope you like it. Thank you.